friends, this video on electricity part 9 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos till part 8 before going ahead with part 9. So let us try to look at some of the problems based on these calculation of equivalent resistance. Let us suppose if a circuit is given like this and I ask you to calculate the equivalent resistance of this circuit between these 2 points A and B. So what will be in order to find out the equivalent resistance, first see how is the current flowing in the circuit. Now these two dots, these two bubbles show that these two are connected to the remaining circuit, I mean some battery or something. So this completes the circuit. So let us suppose some current I flows through the circuit. When I reaches at this point, it has an option to move through this resistance and another option to move through this resistance. But if you look at this resistance is in air. It is not connected to anything. So the current cannot flow through this because current will never flow. I mean, let us suppose if you keep a piece of wire on the ground, will current flow through it? It will not flow, because in order that current flows through a circuit, the circuit has to be a closed circuit. There has to be a battery connected to the circuit which will provide the potential difference between the two ends of the wire. But in this case, if you see, this wire is hanging in air, so no current can flow through this wire. So the entire current will flow through this resistance. So what do you see here? The amount of current flowing through this resistance and this resistance is the same. That means what kind of combination is this? It is a series combination, because same current flows through both the resistances. So what will be the equivalent resistance? Equivalent resistance will be the sum of the resistances, that is 7 plus 5 ohms, which is equal to 12 ohms. So 12 ohms would be the equivalent resistance of this circuit. Let us look at the next problem. Here also we will have to calculate the equivalent resistance between these 2 points A and B. So let us assume that some current I flows through this resistance. It reaches this point. Now it has two options. Either it can move through this path or it can move through this path. Now if you see, if the current moves through this path, it will have to overcome these resistances which will try to oppose the current. But if it moves through this path, there is no resistance at all. So what do you think? Which path will current prefer? So current will prefer to move through this path because there is no resistance along this path. So the entire current will flow through this path and there will be no current flowing through this path. Since no current flows through this path, therefore these two resistances doesn't play any role. So that means the current flows through this 3K resistance and then it flows through 5K resistance. This shows that, so from here we can see that, let us call this as CD. No current flows through CD, and we also see that same current flows through 3 ohms, that is 3K and 5K. Therefore 3 kilo ohms and 5 kilo ohms are in series. So what would be the equivalent resistance? That will be equal to 3K plus 5K, that is equal to 8K. So this would be the equivalent resistance of this combination. Let us look at problem number 3. It says a piece of wire of resistance R is cut into 5 equal parts. These parts are then connected in parallel. If the equivalent resistance of this combination is R dash, then the ratio R by R dash is which of these options? So now you have a piece of wire R which is cut into 5 equal parts. So each part will be R by 5. That means you have 5 resistances, each of resistance R by 5, and you have connected each of them in parallel. So this will how the parallel combination will look like. Both of their ends are joined to each other. So the value of each of them is R by 5. Now the value of equivalent resistance is R dash. So R dash is the equivalent resistance of this circuit. So let us try to calculate the equivalent resistance. Now from parallel combination, we know that 1 by R equivalent is equal to 1 by R dash will be equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4 plus 1 by R5. So now in this case, value of R1 is R by 5. So this becomes 5 by R plus 5 by R plus 5 by R plus 5 by R plus 5 by R. So this gives 1 by R dash is equal to 25 by R, or we can say that R by R dash is equal to 25. So the ratio R by R dash will be equal to 25. So this is the correct answer. Let us look at the next problem. It says that a battery of 9 volts is connected in series with resistors of 0.2 ohms, 0.3 ohms, 0.4 ohms, 0.5 ohms and 12 ohms respectively. How much current would flow through the 12 ohm resistor? So it says that there are these 5 resistors which are connected in series, and there is a battery which is connected to this series combination. So let us suppose this is 0.2 ohms, 0.3 ohms, 0.4 ohms, 0.5 ohms and 12 ohms, and this is a battery of 9 volts. So we have to calculate the amount of current which will flow through the 12 ohm resistor. Right? Now if you look at it, this is the positive terminal of the battery, this is the negative terminal. So current will, the direction of conventional current would be from positive to negative. So that means this is how current will flow. Now since these resistors are connected in series, same amount of current will flow through each of the resistor. So the amount of current which will flow through this 12 ohm resistor is also I. So what will be the value of I? For that, let us calculate the equivalent resistance of the circuit, which will be equal to R1 plus R2 plus R3 plus R4 plus R5, because it is a series combination. So this will become 0.2 plus 0.3 plus 0.4 plus 0.5 plus 12. So this becomes 13.4 ohms. Now applying Ohm's law to this circuit, what do we get? The net voltage potential difference of the circuit V will be equal to I, current flowing through the circuit, into the equivalent resistance of the circuit. So from this we can say I will be equal to V divided by R equivalent. So V is equal to 9 volts divided by 13.4 ohms. So this is equal to 0.671 amperes. So 0.671 ampere current will flow through each of these resistance. So this is the amount of current which will flow through the 12 ohm resistor as well. Let us look at problem 5. It says how many 176 ohm resistors in parallel are required to carry 5 amperes on a 220 volt line. So that means how many resistors do you need such that the resistance of each resistor is 176 ohms, so that you are able to carry a current of 1 ampere on a 220 volts line. So what is the net equivalent resistance needed? So from the entire circuit, how much current do we want? We want a current of 5 amperes. What is the net potential difference across the circuit? That is 220 volt. So according to Ohm's law, V should be equal to I into R equivalent of the circuit. So R equivalent will be V divided by I. That is equal to 220 divided by 5. So this becomes 44 ohms. So this should be the equivalent resistance of the entire circuit. Now let us say that we would need n resistors. So now we have to calculate the value of n. So if I say that I need n resistors to achieve an equivalent resistance of 44 ohms, what does that mean? That means that 1 by R equivalent will be equal to 1 by R1 plus 1 by R2 plus 1 by R3. How many times? N times, because I say that there will be n resistors. Now the value of each of these resistances is 176 ohms. That means their values are same. So we can write 1 by R plus 1 by R plus 1 by R. So how many times? N times I will add. So I can write it this way, that 1 by R equivalent is equal to N divided by R, because adding 1 by R N times means multiplying 1 by R with N. Right? So from this we can say N is equal to R divided by R equivalent. What is R? R is the value of each resistance, which is 176 ohms, and R equivalent is 44 ohms. So this gives 4. So we need 4 resistances in parallel so that it can carry a current of 5 amperes on a 220 volts line. Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.